Hello everyone. Today I am here with you all with the second video on inferential statistics. We are already having a video on the topic in which we have learned what is population, what is sample, what is the difference between the two, what all are the methods of sampling, what is parameter, what is your statistic, what is the difference between the two, what is a sampling error, and what is your central limit theorem. All this we have learned in the first video. Now, in the second video, we will be learning about statistical inferences, the methods of finding it, your t-testing, and the questions related to it. So let's start. Statistical inference. So what a statistical inference is? It is basically a process through which inferences about the population are made based on information from sample. Obtained from sample. That means whatsoever the information we are getting from the sample, from this information we are concluding your population parameters. What we are doing is basically, suppose we have to find a mean for the whole population or standard deviation for the whole population or the variance for the whole population. So instead of working on the whole population, we are working on the sample. Now from the sample, we are making some analysis, some testing we are doing, and from this, whatsoever the information we are getting, from this information, we are concluding all these parameters, like your mean for the population or the variance for the population or your standard deviation for the population, we are concluding for the whole population. Means instead of working on the whole population, we are working with the sample. We are analyzing it, we are concluding it, we are making some testing on it, and as per the information we are getting from all this, we are concluding all these parameters for the population. This whole procedure is known as your statistical inference. So there are three types of statistical inferences are there. First is your point estimation, second is your interval estimation, and third is your hypothesis testing. Now let's see what is estimation. Estimation is basically a process in which we obtain the value of unknown population parameters with the help of sample data. That means from the sample data, we are working on this sample data, and with the help of this sample data, we are getting your unknown population parameter. That means it could be your mean, it could be your variance, it could be standard deviation. So whatsoever is the unknown population parameter, we are getting its value with the help of your sample data. And this whole procedure is known as your estimation. Now let's see what is point estimation. Point estimation involves the use of sample data to calculate a single value of an unknown population parameter. That means what we are doing is we are working on the sample, as just now we are saying. Instead of working on the whole population, we are working on the sample because it is very difficult to work on the whole population. So what we are doing is from this whole population, we are selecting some sample and we are working on this sample. From this sample, with the help of this sample, we are calculating your unknown population parameter. That means it could be your, just now as I said, it could be your population mean. It could be whatsoever the population parameter is there, we are getting a single value of this population parameter. If we are getting a single value of this population parameter with the help of your sample data, then this type of estimation is known as your point estimation. With the help of point estimation, we are getting a single value of population parameter. With the help of your sample data, single value we are getting. Now, this single value of sample data is known as point estimate of corresponding population parameter. That means the single value which we are getting from the sample data, this single value will be known as point estimate of corresponding population parameter. Suppose it is said to you in the question that find the point estimate of your mean population. Right, in that case, what we have to find is basically we have to find your single value of your sample data only. Means from the sample data only we have to find the mean, and whatever the mean will be getting from your sample data, that will be your point estimate of your population. Now, as we are saying, the sample mean, that is your x bar, is a point estimate of population mean. That means if it is given to us that find the point estimate of population mean, that simply means we have to find your sample mean x bar only. That means point estimate of population we have to find. If mu we have to find, in that case we will be calculating your sample mean x bar only. This is only the point estimate of population mean. Similarly, if we have to find a point estimate of population, your standard deviation. That means for the population standard deviation, we have to find the point estimate. That means if we have to find the value of this, in that case, we will be finding sample standard deviation S. The value of sample standard deviation S we will be finding for finding point estimate of population standard deviation. If in the question it is given that find point estimate of population standard deviation, in that case we will be finding your sample standard deviation only. That is value of S we will be finding. So what is the formula for finding sample mean? We have already learned that x bar is your sigma of xi over n, where n is your sample size. And what is the sample standard deviation? S is your square root of sigma of xi minus x bar whole square over n minus 1, where x bar is your sample mean. So using these formulas, we will be finding the values of your point estimate of population mean, or your corresponding population parameters we will be finding. That means point estimate of corresponding population parameters we will be finding. Now let's see a question based on it. The following shows sample of 4 students from a school was taken to see how many books were they carrying. That is your 4, 5, 5, 6. This is the number of books which 4 students are carrying. We have to find what is the point estimate of the population mean, and another is what is the point estimate of the population standard deviation. Just now we have seen if we have to find the point estimate of the population mean, that simply means we have to find the sample mean. This simply means point estimate of population mean means your sample mean, and sample mean x bar is given by sigma of xi over n, where observations are your 4, 5, 5 and 6. It is the observation. So sigma of xi will be your 4 plus 5 plus 5 plus 6 by n. N is your sample size, that is your 1, 2, 3, 4. 4 is the sample size. So we will be dividing it by 4. So 6, 4, 10 and 10 and 10, 20. 20 by 4, that is your 5. That simply means point estimate of the population mean mu will be equivalent to your 5. This will be the value of your point estimate of the population mean. Now second is your, this is the first part. Now the second part is, what is the point estimate of the population standard deviation? If we have to find the point estimate of the population standard deviation, that simply means we have to find sample standard deviation. Sample standard deviation. And just now we have seen that the formula for finding sample standard deviation is square root of sigma xi minus x bar whole square over n minus 1. This is the formula. Now over here x bar, just now we have seen the value of x bar is your 5 only. So xi minus 5 whole square, and that is sigma of that. For your first x1, if we are going to take the first observation, it is your 4 and your x bar is your 5 in all the cases. So first of all we will be taking your 4 minus 5. x1 minus x bar whole square plus, second is your x2. x2 minus x bar whole square plus, x3 is again 5. So x3 minus x bar whole square plus, your x4 is your 6. x4 minus x bar whole square. This is the value of your sigma of xi minus x bar whole square. Sigma means addition, summation. That means we have added all this. First of all, xi means x1, first term, that is your x1, x1 minus x bar. x1 was your 4. So 4 minus 5 whole square. Then your x2, x2 was 5. 5 minus x bar was 5. 5 minus 5 whole square. x3 is your 5. 5 minus 5 whole square. And x4 is your 6. So 6 minus 5 whole square. This is your numerator part. If we will be solving it, 4 minus 5 will be minus 1. Minus 1 whole square will be 1 only, plus 5 minus 5 is 0. So 0 will be here. 5 minus 5 is 0. 6 minus 5 is 1. 1 square will be your 1 only. That means your numerator part, that is summation of xi minus x bar whole square, will be your 2. Value of this will be 2. So it is your root of 2, n, value of n is your 4, because 1, 2, 3, 4. 4 is a number of observation, so value of n is 4. So 4 minus 1, that is your root of 2 upon 4 minus 1 is your 3. If we are going to solve 2 upon 3, it will be your 0.666 will come, so we are rounding it off, so it is your 0.67, and square root of 0.67 is your 0.82. So this will be the value of point estimate of the population standard deviation sigma. Value of sigma will be your 0.82. This is how we will be solving these type of questions. Just now we have seen that what is point estimation. Now let's see what is interval estimation. In interval estimation, we find two numbers using sample statistic between which a population parameter lie. As just now we have said in the point estimation that from the sample we are getting only one value. Single value we are getting from the sample, which is showing your population parameter. But in the case of interval estimation, we are getting two values from the sample statistic. From the sample statistic, instead of one value, we are getting two values, and we are assuming that the population parameter will lie between these two values. That means we are getting the lower limit of it, we are getting the upper limit of it, and between these two limits, your population parameter will lie. If we are talking about the population parameter, that is your mean, in that case mu, that is your population mean, will lie between your L and U, where L is the lower limit and U is the upper limit, between these two values. And these two values we got from your sample statistic. From the sample statistics, we got the value of L and value of U, and between these two values, your population parameter will lie. That means this is mu is an interval estimate of your population mean mu. Mu will lie between L and U. This is what your interval estimation is. In the case, instead of one, we are getting two values from the sample statistic, and we are assuming that the population parameter will lie between these two values. Now, what confidence interval is? Confidence interval is a range of values derived from the sample statistic. As we are saying, the sample statistic, we are getting the two values, that is value of L and U. So this L and U, this range is known as your confidence interval. So this confidence interval is a range of values derived from the sample statistic, which is likely to contain the value of an unknown population parameter. That means this range which we are getting from the sample statistic, which we are assuming that your unknown population parameter will lie between these two values, is your confidence interval. Now this confidence interval is consist of three parts. First is your confidence level, second is your sample statistic, and third is your margin of error. Just now we will see what all these three are. Just we are recalling, just we said that in your CLT, that normal distribution, that if your sample size is either 30 or more than 30, then the distribution will be your normal distribution. That means it will be your bell-shaped curve will be there. Now this over here, this area under this curve, we know that the area under this curve is equivalent to your 1. This is your 1. So here we are assuming that this is your acceptance region. That means this value is rejected, this value is rejected, the value above this will be rejected, and the value below this will even be rejected. The value which will lie between this, that means this area, it is your acceptance region. This is the acceptance region, and this alpha by 2, this is the rejection region, and this alpha by 2, this will be minus alpha by 2, this is even your rejection region. Now the level of significance, what this alpha is known as your level of significance. All this we'll be learning right now only. Alpha is your level of significance. Now see, if level of significance is your alpha, how we can get the value of this confidence level? This is your confidence level. We are assuming that most likely your value of the population parameter will lie between this only, between this range only. So this is your confidence level. So what the confidence level will be? We are saying that the area under the whole curve is your 1. So what 1 is? 1 is equivalent to your confidence level. Confidence level. This is your confidence level and this is your rejection level. So this is your plus level of significance. If we are going to add these two, it will give you your total area under the curve. If we will add this area and these two areas, it will give you the area under the whole curve. That means confidence level, if that is your this area, plus level of significance, which is the combination of this and this. So what level of significance will be? Level of significance will be your alpha by 2 plus alpha by 2. This is alpha by 2, this is alpha by 2. That means it is equivalent to your alpha. Level of significance will be your alpha. And if we are going to add this level of significance and this your confidence level, it will be equivalent to your area under the curve. So we can say the confidence level plus level of significance, we are indicating it by alpha, it is equivalent to 1. So 1 minus alpha will be your confidence level. So confidence level is indicated by your 1 minus alpha. This is your confidence level. We can denote it by 1 minus alpha. Now see over here, if we have to find the population mean, suppose over here the unknown population parameter is your population mean. In that case, what population mean will be? From the sample statistic, we get a value. Suppose this value is your x bar, right? This is your sample mean. Now we will be getting margin of error, which we are assuming that this could be, the error could be there. So this margin of error, if we will be adding and subtracting in the sample mean, we will be getting the value of your population parameter, that is population mean mu value. We will be getting by adding and subtracting this margin of error. If we will be adding this margin of error in the value of x bar, in x bar, if we will be adding this margin of error, we will be getting the value of your upper limit. And if from x bar we will be subtracting this margin of error, we will be getting its lower limit. So how we are getting this lower limit and upper limit? How we are getting this range? That is your confidence interval. How we are getting? If from the sample mean we are adding and subtracting the margin of error, we will be getting its lower limit and its upper limit. Now how to get the margin of error? What is margin of error? What is confidence level? Just now we will be learning how to find all these. Hope it is clear that what is your acceptance region, what is your rejection region. We are assuming this is your acceptance region and these two are your rejection region, and the area under the whole curve is your 1. We are denoting the level of significance, that means addition of this part and this part equivalent to your alpha. So this is the confidence level will be your 1 minus alpha. And the value of your population mean we can get by adding and subtracting the margin error in your x bar, that is your sample mean. Now let's see what is confidence level, what is sample statistic, and what is margin of error. So confidence level, it describes the uncertainty of a sampling method. Confidence level, when written in decimal, it is even called as confidence coefficient. That simply means instead of working on the whole population, we are working on sample. That's the reason there is chances for uncertainty also. So how much confident we are that the value, whatsoever the value we are finding for the population parameter, this value will lie between this lower limit and the upper limit. How much confident we are. This is shown by your confidence level. That means it is a measure of how certain we are that the true population parameter lies within a specific range of confidence interval. As we are saying, if we are finding population mean, that means value of mu, and we are saying it will lie between the values L and U. So how much confident we are that the value of this mu will lie between these two range. This is your confidence level. Now, if we are representing this confidence level in terms of decimal, it is known as your confidence coefficient also. Now, for most of the cases, we are talking about either 90% confidence, 95% confidence, and 99% confidence. So, values for these values, that means these confidence level, 90% confidence level, 95% confidence level, and 99% confidence level is written over here. If your confidence level is 90%, if we are going to represent it in decimal, so 90 upon 100 will be 0.9, 95 upon 100 will be 0.95, and 99% means 99 upon 100 will be 0.99. So this is in percentage and this is in decimal. Now, if your confidence level is this, so what the significance level will be? We have just now seen what significance level is your 1 minus alpha. 1 minus alpha is your confidence level and significance level is your alpha. So if from 1 we are going to subtract your confidence level, then we will be getting the value of your significance level, right? Because see, 1 minus alpha, it is given equivalent to your confidence level. Confidence level. Confidence level is your 1 minus alpha. Just now we have seen that confidence level is your 1 minus alpha. Now what alpha will be? Alpha will be your 1 minus confidence level. If your confidence level is 90%, in that case, your alpha will be 1 minus 90%. 90% means 0.9, 0.9. So 1 minus 0.9, it will be your 0.1 will be the significance level. That means value of alpha will be 0.1. If your value of confidence level is your 0.95, in that case, your significance level alpha will be your 1 minus 0.95, that is your 0.05. If confidence level is your 0.99, in that case, significance level alpha will be your 1 minus 0.99, that will be your 0.01. This is how we'll be getting the value of your significance level. Now, if we are having the value of alpha, we can divide it by 2 and we will be getting the value of alpha by 2. 0.10 divided by 2 will be 0.05. 0.05 divided by 2 will be 0.025 and value of 0.01 divided by 2 will be your 0.005. So for all these values, if we are having the confidence level, if we are having the significance level, we can find the value of Z alpha by 2. Now what Z alpha by 2 is? It indicates how many standard deviations from the mean a data point is, how much deviated it is, and it quantifies the reliability of a statistical survey. How much reliable it is showing that. It is an indication of that. And this value we are getting from the table. When we are having the confidence level, we are having the value of significance level. In that case, from the table, we can find the value of your Z alpha by 2. For these three, which is commonly used, the value of Z alpha by 2 is your this much. 1.645 for 90% confidence level, 1.960 for 95% confidence level, and 2.576 for 99% confidence level. These are the values of your Z alpha by 2. Now what your sample statistic is. So sample statistic is a numerical value basically calculated from sample. So instead of population, we are working on sample. So whatsoever the numerical value we are getting, that means the value of sample statistic we are getting from the sample for estimation of population parameter. Because our whole sole aim is to get the value of your population parameter only. For that only we are working on the sample. So whatsoever the numerical value we are getting from the sample, that is your sample statistic. If we have to find the mean, it will be your sample mean, that is x bar. If we have to find the standard deviation, it will be sample standard deviation, that is your S, like that only. Now what margin of error is? So margin of error is basically the range of value above and below the sample. As we are saying, no, okay, it is your confidence level is your range, it is basically. So how we are getting this range? Just now we have seen, if we are going to add and subtract your margin of error in your sample statistic, whatsoever the value we are getting from the sample statistic, if we are going to add and subtract your margin of error, we are getting your confidence level. Now the confidence level, it is your interval we are getting. Now the range of value above and below the sample statistic is called margin of error. How much above your sample statistic and how much below your sample statistic we have to go, we have to take the range, that is your margin of error. It is a measure of potential error in survey results that arises from using a sample instead of entire population. Because instead of entire population, we are working only on the sample. That's the reason this error is there. And this is known as your margin of error. It is indicated by your capital E. So margin of error can be calculated if we are having the value of sigma. In that case, the formula for finding margin of error is Z alpha by 2. This Z alpha by 2 we are getting from here. From here we will be getting the value of Z alpha by 2. When we are having the confidence level or the level of significance, we can find the value of Z alpha by 2 from the table. So Z alpha by 2 multiplied by sigma divided by root of n, where sigma is your population standard deviation. It will be given in the question. N is your sample size. So if we are having the value of sigma, if we are having the value of n, if we know the confidence level, we can find the value of Z alpha by 2 also. And if we are having all these three values, we can find the margin of error. Now this margin of error, once we are having this margin of error, so how to get the interval estimation of population mean? How we can get it? So interval estimation will be your x bar, that is your sample statistic or the sample mean. In the sample mean, if we will add and subtract your margin of error, we will be getting your interval estimation, right? That means if we will be adding it, if we will be adding margin of error in your sample mean, we will be getting the upper limit, and if we will be subtracting this margin of error from the sample mean, we will be getting its lower limit. So by adding and subtracting margin of error in your sample statistic, we will be getting the interval estimation. The value of L and U we will be getting by adding and subtracting value of E, that is margin of error, in your sample statistic. This is how we will be getting L and U, that is your interval estimation, right? So what Z alpha by 2 shows, already we discussed, that it quantifies your reliability of the statistical survey. It even shows it is a Z value which is providing an area of alpha by 2 of standard normal distribution curve. We have seen standard normal probability distribution curve just now we have seen. So it is showing the area of your alpha by 2. Hope it is clear how to get margin of error, and once we are having the value of margin of error, we can find the lower limit and the upper limit also. Now let's see a few questions based on it. A simple random sample of 49 elements from a population with population standard deviation 7 resulted in a sample mean of 35. Provide a 95% confidence interval for the population mean. So just now we have seen that if 95% confidence interval is there, in that case value of Z alpha by 2 was your 1.96. Here it is given to you that value of N, sample size, is your 49, and your value of sigma, standard deviation, it is given to us as 7, and sample mean, that means X bar, value of sample mean, it is given to us as 35. What we have to find is, we have to find the population standard deviation is already given to us, right? We have to find the population mean. Now what we know is margin of error. The formula for finding margin of error, that is E, it is equivalent to Z alpha by 2 multiplied by sigma over root of 9. This is the value of margin of error. So value of Z alpha by 2 from the table we know it is your 1.96. Value of sigma is given to us as 7. Value of N is given to us as 49. So root of 49, that will be your 7 only, multiplied by 7, root of 49 will be 7, both are going to cancel, it will be your 1.96. So value of margin of error E is your 1.96. Now what we have to find is, we have to find the range for the population parameter, the population mean. So we know that mu, value of population mean, it is given by your X bar minus of E and X bar plus of E. If we are going to add and subtract the value of margin of error in your sample mean, we will be getting the range for your population mean. So value of X bar minus E, it will be, value of X bar is your 35, 35 minus E is, margin of error is your 1.96. So it will be 33.04. And value of X bar plus E, it will be 35 plus value of margin of error is 1.96. So it will be 36.96. So we can say that the value of population mean will vary between 33.04 to your 36.96. This is how we will be calculating it. Now let's see the another question. A 95% confidence interval for a population is reported to be 155 to 165. Already range is given to us. If population standard deviation is 10, value of sigma is given to us as 10. What sample size was used in this study? We have to find the value of N over here. Again, your 95% confidence level is there. Confidence is your 95%. That simply means for 95%, we know the value of Z alpha by 2 is your 1.96. Over here, range is given to us. That simply means we know the value of x bar plus e. Upper limit is given to us as 165. That means x bar plus e is given to us as 165, and value of x bar minus of e is given to us as 155. The value of population mean is varying between 155 to 165. That means value of L, this value is given to us as 155 and this value is given to us as 165. We know that this value we can get by x bar minus e. When we will be subtracting margin of error from your x bar, we will be getting this value. That means x bar minus e is your 155 and x bar plus e is given to us as 165. Now, if we will solve these two equations, simply we need to add, because here it is plus e, here it is minus e. If we will add these two equations, both are going to cancel. X bar plus x bar will become 2 times of x bar. It is equivalent to 0 carry over 1, 6, 12 to carry over 320. So, value of x bar will be 320 divided by 2. 2 1 is 2, 2 6 is 12. So, value of x bar is your 160. Value of x bar, just now we get it as 160. Now, if we are going to keep this value either in this equation or in this equation, we will be getting the value of e, that is margin of error also. So, x bar plus of e, it is equivalent to 165. Value of x bar is your 160 plus e, it is 165. So, value of margin of error will be 165 minus 160, that is 5. So, this is the margin of error. This is your sample mean. Now, we are having the value of sample mean. We are having the value of E. Now, what we have to find is we have to find the value of N. We know that the margin of error is given by Z alpha by 2 multiplied by sigma divided by root of N. This is the formula for finding margin of error. We know the value of margin of error. It is your 5 here. Value of Z alpha by 2 for your 95% confidence, it is your 1.96. Value of sigma is given to us as 10 divided by root of n. Now just cross multiply it. 5 multiplied by root of n, it is equivalent to 1.96 multiplied by 10 will be your 19.6. Now value of root of n will be 19.6 divided by 5. So it will be 5 3s are 15. 4, 5 minus 45, 45 to 4, almost 3.92. Value of root of n will be your 3.92. If root of n is 3.92, so what n will be? We will be squaring both the sides. If we will square both the sides, n will be 3.92 square. And the value for 3.92 square is approximately your 15.37. Now your sample size cannot be in decimals, right? So we will be taking an equivalent to your 15. This is how we will be using these formulas for solving the questions. Now let's see what is hypothesis testing. Hypothesis testing can be used to determine whether a statement about the value of population parameter should or should not be rejected. That simply means we have to assume some statement about the population parameter. Then we have to check whether this statement is true or not. That means whether we have to reject it or whether we have to accept it. So in order to make the decision, it is useful to make some assumption about the population. That means first of all, we will be making some assumption about the population parameter. Whatsoever the population parameter is there, we will be making some assumption about this parameter and then we will be testing it. Now after the testing, we will come to know whether this statement or this assumption, it is to be rejected or it is to be accepted. Such assumptions which may or may not be true are known as hypotheses. The statements which we have made or the assumptions which we have made about the population parameter, it may be true or it may not be true. The such statements or such assumptions are known as your hypothesis. There are two types of hypotheses are there. One is your null hypothesis and another is your alternative hypothesis. Now what null hypothesis is and what alternative hypothesis is, let's see. Null hypothesis says that there is no difference between a parameter and a specific value. That means there is no difference between the two parameters, or there is no difference between the two parameters. It is as per your null hypothesis. That simply means the two groups which we are studying, they are same as per your null hypothesis. And as per alternative hypothesis, existence of difference between a parameter and a specific value or states that there is a difference between the two parameters. That means it says that two groups which we are studying, they are not same. There is difference between the two parameters. That means two groups studying are your different. Now let's see how to generate the null hypothesis and alternative hypothesis. Suppose Blinkit claims that its average delivery time is 10 minutes, but you believe that it takes more than 10 minutes. So set the appropriate hypothesis. Now what we can say is, according to your null hypothesis, it is delivery time is less than 10 minutes, either 10 minutes or it is less than 10 minutes. So in that case, your hypothesis is, null hypothesis will be, your mu, value of mu will be less than equivalent to your 10 minutes. Now what is null hypothesis? Just opposite of that will be your alternative hypothesis. So alternative hypothesis says that your value of mu will be greater than your 10. This will be your alternative hypothesis. Now the another is, the mean income of executives of a company is rupees 9 lakh per annum. To test it, it is decided to take sample of 20 executives and obtain their mean income. Now set the appropriate hypothesis. Now over here, mean income is given to us as your 9 lakhs per annum. So we are assuming that both the things, both the groups we are studying are same. So as per your null hypothesis, value of mu will be equivalent to your 9 lakh. 9 lakh rupees per annum will be the value of mu. And just opposite of it will be your alternative hypothesis. So alternative hypothesis will be, value of mu will not be equivalent to your 9 lakh rupees. So this will be your alternative hypothesis, just opposite to of your null hypothesis. Now let's see hypothesis test for population mean. When your sigma is known, in that case, hypothesis test about a population may take any of the three forms. Three forms of the hypothesis test is possible. One, when your null hypothesis says that mu is less than equivalent to mu 0, and just opposite of it will be your alternative hypothesis, that is mu is greater than mu 0. The second condition could be, your null hypothesis says that mu is greater than equivalent to mu 0, and your alternative hypothesis says that mu is less than your mu 0. The third condition is that your null hypothesis says that mu is equivalent to mu 0, and alternative hypothesis says that mu is not equivalent to mu 0. Just opposite of your null hypothesis will be your alternative hypothesis. Over here we can see, over here null hypothesis says that mu is less than equivalent to, so alternative hypothesis was saying that mu is greater than. If it is your greater than equivalent to in the null hypothesis, in the alternative hypothesis it is your less than. And if in the null hypothesis it is equivalent to, then in the alternative hypothesis it is not equivalent to. Just opposite to the null hypothesis, it is your alternative hypothesis. Now what mu 0 over here is, mu 0 denotes the hypothesized value of population mean, mu. Whatsoever the hypothesized value we have taken, that is your mu 0. If we are going to see over here, this is your form of your one-tailed form. This type of formation of your alternative hypothesis and your null hypothesis is your one-tailed form. This is even your one-tailed form, and this is your two-tailed form. This type of form, it is your two-tailed form, and these two both are known as your one-tailed type of form. Now why it is called one-tailed form and why it is called two-tailed form, just now we will be seeing. Over here what we are doing in hypothesis test, in hypothesis test we will be assuming that whatsoever is the null hypothesis we have assumed, it is going to reject. Our assumption will be that your null hypothesis is going to reject. It will be our assumption, and if it is going to reject, it is but obvious that HA, that is your alternative hypothesis, will be true. So our assumption will not be that HO is going to be accepted. We will be assuming that your null hypothesis will reject. And if it is going to reject, that simply means your alternative hypothesis is going to be accepted. Now, whatsoever the assumption we have made, if our assumption is true, that means if your alternative hypothesis is true, then in that case what we are going to conclude it, that we are going to reject the your null hypothesis, and alternative hypothesis is true if your assumption is true, because what we had assumed was your null hypothesis is going to be rejected and your alternative hypothesis will be true. This was our assumption. So if our assumption is true, that means we can conclude that alternative hypothesis is true. And if our assumption is false, whatsoever we had assumed is false, then we will be concluding that null hypothesis is true. Is it clear that our assumption is that null hypothesis is going to reject and your alternative hypothesis will be true? This was our assumption. And if our assumption is true, that simply means alternative hypothesis will be true. And if our assumption is false, in that case we will be saying that null hypothesis is true. Now, how we are going to represent it? As just now we have said, your normal distribution, this is your normal distribution. So this is the condition when your value of mu should be less than equivalent to your mu 0, that is your hypothesized value. So this is your hypothesized value, say mu 0. This value is your hypothesized value mu 0. That means this is the condition when your alternative hypothesis will be true. If the value of mu 0 will be greater than this mu 0, in that case your alternative hypothesis will be true. Otherwise, for these values, for this much values, your null hypothesis will be true. Over here we can see that null hypothesis says that mu is less than equivalent to mu 0. That simply means if this is your mu 0 and value of mu, this is value of mu, that is your population parameter, population mean. If the population mean is greater than or equivalent to your mu 0, then your null hypothesis will be true. So your null hypothesis will be true if value of mu will be less than equivalent to your mu 0. This is how we will be representing this condition. And alternative hypothesis will be true when your mu will be greater than mu 0. If the value of mu will lie somewhere here, that means it will be greater than mu 0. In that case, your HA, alternative hypothesis, will be true. Now, because there is only one tail, these two are the tails. This is one of the tail, this is one of the tail. Because in this condition, only one tail is considered. That's the reason it is your one-tailed form. Now, for this condition, we are drawing the distribution figure. Now see over here even your null hypothesis says that mu is greater than equivalent to mu 0. So mu 0 will lie somewhere here. This is your mu 0. This value is your mu 0. If the value of mu is greater than equivalent to mu 0, if it is greater than equivalent to mu 0, if this is the condition, then your null hypothesis is true. Mu is greater than equivalent to mu 0, that simply means when your population mean is greater than this value mu 0, in that case your null hypothesis will be true. And if value of mu is less than mu 0, that means if this is the condition, in that case your alternative hypothesis will be true. Again, there is only one tail. That's the reason this type of formation will be your one-tailed form. Now, if we are going to see the third condition, so its normal distribution will be like this again. Here, mu is equivalent to mu 0. So, this is your mu 0. It is not only the mu 0, it is the interval. As we were saying, from here to here. So, it is even the same condition. So, this is the number. If the value of mu is less than this value, in that case, it is going to fail. That means if the value of H0 is equivalent to mu 0, it is given to us. So it is not only the mu 0, it is the interval we'll be considering. That means from here to here. If your condition is satisfying from here to here, if the value of mu is from here to here, in that case, your null hypothesis is going to be true. HO, null hypothesis will be true. And if its value is lying somewhere here, or somewhere here, in that case your alternative hypothesis will be true. over here in this condition, if your mu, the value of mu is not equivalent to this area, in that case it is going to be your alternative hypothesis is going to be true. And if the value of mu is lying somewhere here, in that case your null hypothesis is going to be true. That means the value of your mu should be greater than this value and should be less than your this value. It should lie somewhere here. If the value is lying somewhere here, your null hypothesis will be true, and if it is less than this value and if it is greater than this value, in that case your alternative hypothesis will be true. Now because here two tails are there, one tail over here, one tail over here, that's the reason this is your two-tailed form. This form is known as your two-tailed form. This is how it is being represented on your map, on your curve. This is how it is going to be represented. Now let's see what is degree of freedom. The number of independent pieces of information on which an approximation is based is known as degree of freedom. Now let's understand this with an example. Suppose I'm saying that I'm having 5 chocolates and 5 kids are there. So how many of them will be having choice to select the chocolate? Suppose I'm saying the first kid to take any of the chocolate. So he is having 5 options. Out of these 5 chocolates, he could have selected any of the chocolate. Now for the second kid, there are 4 options are there. Out of these 4 chocolates, he'll be selecting any one chocolate. Now for the third kid, there are 3 options are there. Out of these 3 chocolates, he could select any one. Now for the fourth one, there are 2 options are there. Out of these 2 chocolates, he could select any one of the chocolate. But for the last, 5th kid, there is no option. He is not having any choice. There is no choice that he could select this chocolate or that chocolate. He has to select the last one chocolate only. He is not having any choice for the selection. So in such cases, if the number of observation, that is your n, in that case n minus 1 will be the degree of freedom, because the last one is not having any choice of the freedom. He is not having any choice that he can select this or that. There is no choice like that. That's the reason degree of freedom will be your n minus 1. So if one sample testing we are doing, in that case degree of freedom will be your n minus 1. And if 2 sample testing we are doing, in that case degree of freedom will be n1 plus n2 minus 2. Now let's take some examples. Evaluate degree of freedom for given sample. So over here, what is the value of n? 1, 2, 3, 4, 5, 6, 7. Value of n is your 7. So degree of freedom will be your n minus 1, that is 7 minus 1. 6 will be the degree of freedom. Now let's take another example. Determine degree of freedom for the sequence given below. Over here, there are 2 sample tests is there. One is here, another is this. So for this condition, n is 1, 2, 3, 4, 5, 6. So value of n1 is your 6. And for this condition, 1, 2, 3, 4, 5. Value of n2 is your 5. So degree of freedom will be n1 plus n2 minus 2. That is n1 is your 6. n2 is your 5 minus 2, that is 6 plus 5 will be 11 minus 2, that means degree of freedom will be your 9. So this is how we can get the value of degree of freedom. Now let's see what is t-test. A t-test is a statistical test that is used to compare the two groups which may be related in certain features. That means when we have to compare any two groups which are related in any of the feature, then we use t-testing. It is often used in hypothesis testing. That means when we have to conclude whether your hypothesis test will be accepted or your alternative hypothesis will be accepted, in these type of testing, we are going for your t-testing. It is also called student t-test. There are mainly 3 types of t-test. One is your one sample t-test, 2 sample t-test, and your paired t-test. Paired t-test is not in our syllabus. So here we will be learning about one sample t-test and your 2 sample t-test. So what we are doing in t-test is the inferential statistic calculated in t-test is called t-ratio and is denoted by t. So first of all, we will be calculating the value of t, which is your t-ratio. How we will be getting the value of t-ratio, what the formula will be using, that we will be learning right now. So first of all, we will be calculating the value of t. And the larger the t-ratio, the more likely we will reject null hypothesis. And if the value of t will be more, In that case, it simply means we are going to reject the null hypothesis. That means H naught we are going to reject if the value of t will be more, because of more evidence in data that the two groups different from each other, because the more value of t reflects that there are two groups which we are comparing, they are different from each other. That's the reason if the value of t will be more, that simply means we are going to reject your null hypothesis. So what we are doing is, first of all we are calculating the value of t. After that what we'll be doing is, we will be calculating the critical value t alpha. We have got the value of t, now we will be taking the value of t alpha. From where we will be getting the value of t alpha? It is, we are getting from your table. That is from t distribution table we will be getting the value of t alpha, and the value of t alpha depends on your degree of freedom. Just now we came to know, we have learned that what degree of freedom is. So from the degree of freedom, if we are knowing the degree of freedom from the table, we can get the value of critical value, that is your t alpha. From the formula we got the value of t, from the table we got the value of your t alpha. Now what we'll be doing is critical value approach, that is rejection rule using critical value. From this critical value, what will be the rejection rule, that we'll be learning. So three conditions are there. Just now we have already learned that three conditions are there. One is your lower tail test. So what lower tail test is? In that your null hypothesis says that the value of mu is greater than equivalent to your mu 0. And alternative hypothesis is just opposite of it, that is value of mu will be less than your mu 0. That means this type of curve will be there, this is your curve will be there, and if this is your t alpha, minus of t alpha, obviously it is, this is your negative side, so this is your minus of t alpha. That simply means if the value of t, which we will be getting from the formula, if the value of t will be greater than this, will be greater than this minus of t alpha, that means comes in this region, in that case our null hypothesis will be accepted. It will be true, it is going to be accepted if the value of t, that is t ratio, will be more than your minus of t alpha. If this is the value, in that case your null hypothesis will be accepted, and if the value of t is less than your minus of t alpha, that means this is the region, if this is the region coming, in that case our alternative hypothesis will be true. That simply means what we are doing is, we are getting the value of t from the formula, we are getting the value of t alpha, that is critical value, from the table, and then we'll be comparing. If the case is your lower tail test, in that case if the value of t is more than your minus of t alpha, that is it is coming in this region, in that case your null hypothesis will be true, it will be accepted, and if its value is less than minus of t alpha, in that case your alternative hypothesis will be true, it is going to be accepted. Now what is the rejection rule says? That we are going to reject hypothesis, your null hypothesis will be rejected. When it will be rejected? When it is going to come in this region, then only your null hypothesis will be rejected, because this is the case when your null hypothesis will be rejected or your alternative hypothesis will be accepted. So when your your null hypothesis will be rejected if the value of t is less than equivalent to your minus of t alpha. If the value of t which we are getting from the formula, if it is less than your minus of t alpha, in that case your null hypothesis is going to be rejected. Or we can say, if absolute value of it, that means instead of negative we will be taking your positive value, if this positive value is greater than your t alpha, in that case also your null hypothesis is going to be rejected. So any of the two conditions we can take, both are same only. If we are taking the negative value, in that case if the value of t, if the value of t, that is t ratio, is less than your minus of t alpha, that is coming over here, in that case your null hypothesis will be rejected. Or if instead of this I am going to take the positive value, because see, if this is your minus of t alpha, that your t will even be negative, so I have taken it as positive because I have taken its absolute value, so your sign is going to change. That means if the absolute value of t is greater than your t of alpha, if the absolute value of t is greater than your t alpha, that means over here if it is your minus of 2, so here it will be minus of 3, so absolute value of minus of 2 will be your 2 and absolute value of minus of 3 will be 3. That means if the absolute value of t is greater than t alpha, in that case your null hypothesis is going to be rejected. This is the first condition. Now the second is your upper tail test. So for that graph will be something like this. This is your upper tail test. Obviously these are your one tailed only because only one tail is there in both the two conditions. Now what your upper tail test hypothesis is, according to it your null hypothesis is mu is less than equivalent to mu 0, and your alternative hypothesis is mu is greater than your mu 0. Just opposite of your null hypothesis will be your alternative hypothesis. Now in this case, if the value of t is lying somewhere here, in that case your alternative hypothesis is going to be accepted. That means alternative hypothesis will be true, or we can say your null hypothesis will be rejected if the value of t is greater than your t alpha. If the value of t will be greater than your t alpha, in that case alternative hypothesis will be true, or we can say your null hypothesis will be rejected. And if the value of t is lying somewhere here in this area, in that case your null hypothesis will be accepted. It is going to be accepted. So rejection rule says that we are going to reject the null hypothesis if the value of t is greater than equivalent to your t alpha. If the value of t is lying here, it is greater than your t alpha, in that case your null hypothesis is going to be rejected. Or we can say mod of t, that is your absolute value of t is greater than your t alpha, in that case your null hypothesis is going to be rejected. And if it is less than this, if the value of t is less than your t alpha, then this will be the region, and over here your null hypothesis will be accepted. Now the third condition, that is your two-tailed test. Over here we are having two tails. So your null hypothesis says that mu is equivalent to mu 0, and your alternative hypothesis says mu is not equivalent to your mu 0. Just opposite to your null hypothesis is your alternative hypothesis. Now if the value of t is lying either here or it is lying either here, in these two cases your alternative hypothesis will be accepted, or we can say your null hypothesis will be rejected if the value of t will lie either here or here. In both the two cases, because two tails are here, so it is two-tailed test, and if the value of t is either lying here or lying here, in that case your null hypothesis is going to be rejected, or your alternative hypothesis will be accepted. Now this is over here, it is your t alpha by 2, this value, and this value is minus t alpha by 2. If we will take it together, alpha by 2, it will become alpha even. So this whole, your significance, level of significance will be alpha, and this value in both the two cases your null hypothesis is going to be rejected. So rejection rule says if the value of t, which we are getting from the formula, if it is less than equivalent to your minus of t alpha by 2, if it is less than this value, over here it is your minus t alpha by 2, if this is the value minus of less than minus t alpha by 2, or if it is greater than your t alpha by 2, this is your t alpha by 2, if it is greater than this, in both the two cases your null hypothesis will be rejected. And if it is lying somewhere here, it is your null hypothesis is going to be accepted. This is the condition. So we can say in all, if instead of negative sign I am just converting into positive sign, so it will become mod of t. That means absolute value of t we are calculating, and if absolute value is greater than equivalent to t alpha by 2, in that case your null hypothesis is going to be rejected. So if we are taking the positive values, then your conditions will be this, and if we are going to take the negative values, then it will be this. So if we will take the positive values, always we are ignoring the negative values, then we can say always mod of t, that means absolute value of t is greater than equivalent to t alpha, then we will be rejecting your null hypothesis. Same over here, absolute value of t is greater than equivalent to t alpha, then your null hypothesis will be rejected. And absolute value of t is greater than equivalent to t alpha by 2, because it is two-tailed test, so alpha by 2, so instead of t alpha we will be taking over here t alpha by 2, in that case your null hypothesis will be rejected. So it is easy to remember that mod of t, if we will be taking absolute value, it is always the same sign, absolute value is greater than equivalent to, in all the three conditions. So this is how we will be testing whether your null hypothesis will be accepted or it is going to be rejected. Now let's understand one sample t-test. In testing the null hypothesis that the population mean is equivalent to hypothesized value mu0, we use this test statistic. That means what is our null hypothesis? As per our null hypothesis, your population mean, that means value of mu, is equivalent to your hypothesized value, that is your mu0. This is our null hypothesis. So what alternative hypothesis will be? It will be your population mean is not equivalent to your hypothesized value, that is mu0. That will be your alternative hypothesis. Now how we will be testing? First of all, we will be calculating the value of t, that is your t ratio. We will be calculating this value, and this is given by the formula x bar minus mu0 over s divided by root of n. If the value of n, that is sample size, is greater than equivalent to 30, we will be using this formula for finding t ratio. That is t equivalent to x bar minus mu0 over s upon root of n. This is how we will be getting the value of t. And if the value of n is less than 30, in that case value of t is given by x bar minus mu0 over s upon under root of n minus 1. This will be the value of t if the value of n is less than 30. Now let's understand what x bar is, what mu0 is, what all these are. So x bar is your sample mean. We know that the value of x bar is your sample mean, and n is your sample size. S is your sample standard deviation is your s, and mu0 is your hypothesized value of population mean. So all these are will be given in the question. We have to find the value of t, and then from the degree of your freedom, we will be getting the critical value, that is your t alpha. Then we will be comparing, and we will be just checking what the rejection rule says. From here we get the value of t. Now for one-tailed test, that means either your upper test or the lower test, that means either this is the condition or either this is the condition. In both the two conditions, that is your one-tailed test, your rejection rule says that the absolute value of t is if it is greater than equivalent to your t alpha. If the absolute value of t is either greater than or equivalent to t alpha, in that case your null hypothesis will be rejected. That means your alternative hypothesis will be accepted if your absolute value of t will be greater than equivalent to your t alpha. And in the case of your two-tailed test, that means this is the condition, this is a two-tailed test. In this case, your rejection rule says that if the absolute value of t is greater than equivalent to t alpha by 2, because two-tailed test it is, so it is your t alpha by 2, it is your t alpha by 2. So if the absolute value of t is either greater than equivalent to your t alpha by 2, then your null hypothesis will be rejected or your alternative hypothesis will be accepted. So this is how we will be checking it, we will be concluding it. Over here, alpha is your level of significance, t alpha is the critical value which we will be getting from the table, t distribution table. Degree of freedom is your n minus 1. Whatsoever the n is there, n minus 1 will be the degree of freedom. So once we are having the value of degree of freedom, we can find the value of t alpha, that is your critical value from the table. Now let's understand few questions based on the concept. 10 machines are taken at random from an industry. The mean net weight of machine is 48.5 kg and a standard deviation of 2.5 kg. Does the sample mean differ significantly from the intended weight of 50 kg? Given to us is that t at 0.05, that is alpha is your 0.05, the value of t alpha is 2.262 if your degree of freedom is your 9. So what is given to us over here is that your sample size n is your 10, it is given to us, and the mean net weight of machine is 48.5 kg. That means value of x bar is 48.5 kg. This is the value of your x bar. Then your standard deviation is given to us as S is 2.5 kg, it is given. Does the sample mean differ significantly from the intended weight of your 50 kg? That means mu0 is given to us as your 50 kg. Now what your null hypothesis will be? Null hypothesis will be that value of mu is equivalent to 50 it is your null hypothesis. And just opposite to it will be your alternative hypothesis, that is mu is not equivalent to your 50. This will be your alternative hypothesis. Now see over here, value of n is 10, and we have learned that if the value of n is less than 30, in that case t ratio is given by x bar minus mu 0 over s under root n minus 1. Instead of n over here, we will be using n minus 1. So keep the values over here. Value of x bar is 48.5, mu 0 is 50, divided by s is 2.5, divided by n is your 10, so it is 10 minus 1, that is your 9. Root of 9 will be your 3, and this will go in the numerator. If we will solve it, 48.5 minus 50, it is minus of 1.5. So minus of 1.5 multiplied by this root of 9 will go in the numerator, will become 3 divided by your 2.5. If we will solve it further, 1.5 multiplied by 3 will be minus of 4.5 divided by your 2.5. Both the decimals will be removed. 5 is 25, 5 9 is 45. So it will be minus of 5 1 is 5, 4 5 8 is 40. So value of t will be minus of 1.8. Now if this is the value of t, so absolute value of t will be your 1.8, because we will be ignoring the negative sign, and it will be absolute value will be your 1.8. If this is your 1.8, value of t alpha is given to us as 2.262. Value of t alpha is given to us as 2.262. Here degree of freedom will be n minus 1. We know the degree of freedom is your n minus 1. N is 10 here, so 10 minus 1 will be 9. At 9 degree of freedom, the value of t alpha, that is alpha is 0.05. The value of t alpha is your 2.262. From table we can get this value. Now t alpha is 2.262. It is given to us, and absolute value of t, just now we have calculated, it is your 1.8. So rejection rule says reject HO if value of absolute value is greater than your T alpha. If this value, absolute value of T is greater than T alpha, in that case we will be rejecting your null hypothesis. Over here we can see that value of T, that is absolute value of T is 1.8. It is your less than your T alpha, because T alpha is 2.262. This is the value of T alpha, and absolute value of T is your 1.8, which is less than your T alpha. That simply means your null hypothesis will be accepted. We are not going to reject your null hypothesis, because null hypothesis will be rejected when your absolute value of T is greater than your T alpha. But here the absolute value of T is less than your T alpha. That's the reason your null hypothesis will not be rejected. It is going to be accepted. That simply means if it is going to be accepted, we are going to accept it, then does the sample mean differ significantly from the intended weight of 50 kilograms. So we are going to reject. We are not going to reject your null hypothesis. We are going to accept your null hypothesis. So it is not going to differ significantly from the intended weight of your 50 kilogram. Now let's see the another question. Consider following hypothesis test. Over here already hypothesis test is given to us. That is H naught is mu is greater than equivalent to 240, and your alternative hypothesis is mu is less than your 240. That simply means this is the value of your mu 0. Mu is greater than equivalent to your mu 0. So this 240 is the value of your mu 0. So mu 0 is given to us as your 240. A sample of 100. That means value of n is your 100. Provided a sample mean x bar is 245 and sample standard deviation 25. Compute the value of test statistic and degree of freedom. So degree of freedom, we know the value of degree of freedom is n minus 1. This is the value of degree of freedom. So it will be 100 minus 1, that is 99 will be the degree of freedom. And the value of t is given by x bar minus mu over s over root of n, because value of n is greater than 30. So we will be using this formula. So it will be value of x bar is 245, value of mu 0 is 240 divided by value of s is 25 and value of your n is 100. 245 minus 240 will be 5 divided by, this is 25, root of 100 will be 10, which will go in the numerator, so it will be multiplied by 10, so it will be 50 divided by 25, that is your 2. Value of t will be your 2. Here we can get the value of t, which is your 2. Now the value of t alpha is given to us as at degree of freedom 99. Degree of freedom was your 99. At degree of freedom 99 and your level of significance 0.05, value of t alpha is given to us as 1.66. We can get it from the table also. So it is your 1.66. Now we can compare the value of t and your t alpha. Your rejection rule says, second part is what is the rejection rule using critical value. So rejection rule says that reject your H0 if absolute value of t is greater than your t alpha. If the absolute value of t is greater than t alpha, then in that case we will be rejecting your H0. If we will be rejecting over here, then simply means see, value of t is 2 and value of t alpha is 1.66. So yes, your value of t is greater than your t alpha, because this is 2 and this is a 1.66 and 2 is greater than your 1.66. That's the reason we are going to reject your null hypothesis. Null hypothesis will be rejected. That simply means your null hypothesis says that value of mu is greater than equivalent to 240. So it is going to be rejected. This is your conclusion. That is your third part. So this is how we will be solving. First of all, we will be finding the value of t. We will be getting the value of t alpha from the table. It depends upon the degree of freedom and your level of significance. Then we will be comparing these two. If the value, absolute value of t will be greater than your t alpha, in that case we will be rejecting your null hypothesis. And if the value of t is less than your t alpha, in that case we will be accepting your null hypothesis. Over here we will be accepting the null hypothesis. That means there is no much difference is there. There is sample mean does not differ significantly from the intended weight. Over here your null hypothesis was mu is greater than equivalent to 240, which we are going to reject. That means we are accepting the alternative hypothesis. Accepting your alternative hypothesis, which says value of mu, that is your population mean, will be less than your 240. Now let's understand two sample t-test. In a statistical hypothesis testing, a two sample t-test is a test performed on the data of two random samples, each independently obtained from a different given population. That means two different populations are there. From these two different populations, we have taken two samples. Mu1 will be the population mean for the first group. Mu2 will be the population mean for the second group. Now from the first population, we have taken first sample and the mean for that first sample will be your x1 bar. And the population from the population 2, we have taken the sample and the mean of that sample will be your x2 bar. N1 is the sample 1 size and N2 will be the size of your sample 2. That means two populations were there. Suppose one of the population is 1, another population is 2. For this whole population, mean will be your mu1. For the whole population 2, your mean will be your mu2. Now from these two, we have taken two samples. From the first, we have taken the sample and that mean of that sample will be your x1 bar. From the second population, we have taken the sample and mean of that sample will be your x2 bar. The size of the first sample is your n1 and the size of the second sample will be your n2. Now, the purpose of the test is to determine whether the difference between the means of these two populations is statistically significant. That means whatsoever the population mean difference is there, whether it is significant or not. So what will be the difference between these two means? It will be your mu1 minus mu2. And generally we are taking it to be 0. It is denoted by your D0 and generally we are taking the difference between these two population means to be 0. That means value of D0, that is your mu1 minus mu2, we are taking it to be 0. And if this is the case, in that case mu1 will be equivalent to your mu2. If your D0 is your 0, that means difference between these two population means is your 0. Now the hypothesis will be again three conditions will be there: lower tail test, upper tail test and two tail test. For the lower tail test, your mu0 will be, your hypothesis, null hypothesis will be mu1 minus mu2 will be greater than equivalent to d0. That is, your d0 is your difference between these two population means. In most of the cases it will be 0. Over here I am writing it to be d0 only, but in most of the cases d0 will be your 0 only. So if this is your null hypothesis, alternative hypothesis will be just opposite of it. That means mu1 minus mu2 is less than d0. Now for the upper tail test, your null hypothesis will be mu1 minus mu2 is less than equivalent to d0, and alternative hypothesis will be mu1 minus mu2 is greater than d0. Two-tailed test, it will be null hypothesis will be mu1 minus mu2 is d0, and your alternative hypothesis will be mu1 minus mu2 is not equivalent to your d0. This will be your hypothesis. But in most of the cases, because we are taking d0 equivalent to 0, that's the reason your null hypothesis will become, this part will become 0. And if your d0, that is your mu1 minus mu2 will become 0, in that case what will be the condition? The null hypothesis will become mu1 is equivalent to mu2. That means two population means are equal. The population mean we are getting from the first population, the population mean we are getting from the second population. The difference between these two is 0. That means both of them will be equal. So null hypothesis will be mu1 is equivalent to mu2, and just opposite of it, alternative hypothesis will be that mu1 is not equivalent to your mu2. That means two population means are not equal. Now two conditions will be there. The first condition is when your variances are assumed to be equal. For the first condition and for the second condition, your variances are suppose S1 and S2. If these two S1 and S2 both are equal, in that case your degree of freedom will be n1 plus n2 minus 2. If S1 is equivalent to S2, in that case degree of freedom is given by n1 plus n2 minus 2. And your T ratio will be given by x1 bar minus x2 bar over S multiplied by square root of 1 over n1 plus 1 over n2. This is how we will be getting the value of T. From degree of freedom and from your significant level of significance, we will be getting the value of critical value, that is T alpha. From the table we will be getting, and from here we will be getting the value of T ratio, that is your T. Right? Now if D0 is not 0, over here we are assuming that D0 is your 0, but if D0 is not 0, in that case your T ratio will be given by x1 bar minus x2 bar minus of d0 divided by under root of s1 square over n1 plus s2 square over n2. If s1 will be equivalent to s2, in that case it will become x1 bar minus x2 bar minus d0 over s will come out of it, and it will be 1 over n1 plus 1 over n2. And if s1 is not equivalent to s2, in that case this is how we will be getting the value of T ratio. Minus d0 will even be included. Now if it is d0 is 0, in that case it will become x1 bar minus x2 bar divided by s under root 1 upon n1 plus 1 upon n2. This is the condition when your s1 is equivalent to s2, and in this condition your degree of freedom will be n1 plus n2 minus 2. Now if your S1 is not equivalent to S2, in this condition your degree of freedom is given by S1 square over N1 plus S2 square over N2 whole square divided by 1 over N1 minus 1 in the bracket S1 square over N1 plus 1 over N2 minus 1 in bracket S2 square over N2 whole square. This is how we will be getting the value of degree of freedom if your S1 is not equivalent to S2. And the value of T will be in that case x1 bar minus x2 bar divided by under root of s1 square over n1 plus s2 square over n2. This is how we will be getting the value of T if s1 is not equivalent to s2. And if in the same way, if your D0 is not equivalent to 0, then the formula will be x1 bar minus x2 bar minus D0 will even be included divided by s1 square over n1 plus s2 square by n2. This is the condition when your s1 is not equivalent to s2, and this is the condition when your s1 is equivalent to your s2. Now we are having the value of T ratio. from your table, T distribution table, we will be getting the value of your T alpha also. That means your critical value also will be getting. How we are getting the critical value? It depends upon your degree of freedom and your level of significance. We can calculate the degree of freedom. In case of S1 equivalent to S2, it will be N1 plus N2 minus 2. In case when S1 is not equivalent to S2, this is how we will be getting the value of degree of freedom. Now, once we are having the degree of freedom, we can calculate your critical value T alpha. We are having the value of T also. We are having the value of T alpha also. Then what the rejection rule says, if it is one tail test in both the conditions, whether it is S1 is equivalent to S2 or S1 is not equivalent to S2, in both the condition, your rejection rule says that for one tail test, reject your null hypothesis if your T value of absolute value of T is greater than equivalent to your T alpha. If it is the case, then reject your null hypothesis. And for two-tailed test, reject your null hypothesis if value of absolute value of T is greater than equivalent to your T alpha by 2. The same conditions will be there for both the two cases. That means once we are having the value of T, once we are having the value of T alpha, then we will be checking the rejection rule. We will be rejecting H naught, that is a null hypothesis, for one tail test if absolute value of T will be greater than equivalent to T alpha. And for two tail test, we will be rejecting your null hypothesis if absolute value of T will be greater than your T alpha by 2. Now let's understand question based on the concept. The average number of parts produced by two machines per day are 500 and 550, with standard deviation 50 on the basis of records of 25 days. Can you regard both the machines equally efficient at 1% level of significance? So what all is given to us is your two sample, one sample mean is your 500, x2 bar is your 550, your standard deviation S is same, that is your 50, your N1 is equivalent to N2, that is your 25 days, and alpha value of alpha level of significance is given to you as 1%, that is your 0.01. It is given to us, and T alpha is given to us as 2.68. Over here we can see that it is your null hypothesis. If we are going to generate it, it will be mu1 is equivalent to mu2. It is your null hypothesis because it is said, can you regard both the machines equally efficient? That means mu1 is equivalent to mu2. It will be your null hypothesis. And alternative hypothesis will be your mu1 is not equivalent to your mu2. This will be your alternative hypothesis. Now over here we can see that the value of x1 bar is 500, x2 bar is 550. S is same for both the two conditions. If S is same, we have seen that the value of T will be x1 bar minus x2 bar over S under root 1 over N1 plus 1 over N2. This is the condition when your S1 is equivalent to your S2 and variance is same. If we are going to keep these values, it will be x1 bar is your 500 minus 550 divided by S is your 50 under root of 1 over 25 plus 1 over 25. This will be the value of T. If we will solve it further, it will be minus of 50 over 50 under root of 2 over 25. 50 and 50 both are going to cancel. Square root of 25, it is going to reciprocate. It will be root of 25 by 2. Root of 25 is your 5. So minus of 5 by root 2. Value of root 2 is your 1.414. So it will be around minus of 3.5. Say approximately this will be the value. Now here see when S1 is equivalent to S2, in that case your degree of freedom. Degree of freedom is your N1 plus N2 minus 2 will be the degree of freedom, and degree of freedom N1 is your 25. So 25 plus 25 minus 2, that is 50 minus 2, that will be 48. That means for the degree of freedom 48 and your level of significance, that is your 1%, your T alpha, that is critical value T alpha will be your 2.68. It is given to us. So T alpha is given to us as your 2.68. It is regarding your degree of freedom 48, because when S1 is equivalent to S2, then degree of freedom is N1 plus N2 minus 2. This is the degree of freedom, and this is how we have calculated the value of T. Now rejection rule says then absolute value of t, if absolute value of t is greater than your t alpha, then we are going to reject your null hypothesis. In that case, we will be rejecting null hypothesis. Now over here we can see the value of absolute value of t. Absolute value of t is your 3.5, because it was originally the value of t was minus of 3.5, but absolute value, when we will be calculating, we will be ignoring this minus sign. So absolute value of t will be your 3.5, and this absolute value of t, and t alpha is your 2.68. So absolute value of t is greater than your t alpha. This condition is satisfied. That simply means we will be rejecting your null hypothesis, will be rejected, and we are going to accept your alternative hypothesis. So null hypothesis will be rejected. That means your mu1 will not be equivalent to your mu2, because we will be accepting your alternative hypothesis. That simply means both the machines are not equally efficient. They are not equally efficient, because your null hypothesis was saying that they were equally efficient, but your null hypothesis was rejected. That simply means both the machines are not equally efficient. Now let's see the another question. Consider following hypothesis test H0, that is your null hypothesis is mu1 minus mu2 is less than equivalent to 0. What this is your D0, value of D0 is your 0 only, and alternative hypothesis is mu1 minus mu2 is greater than 0. This is your hypothesis are already given to us. For sample 1, your n1 is 16, sample 2 n2 is 12, x1 bar is 525, x2 bar is 487, s1 is 57.5, s2 is 49.5. All these values are given to us. Now what is the value of test statistic? Now over here we can see s1 and s2 both are different, right? So what the value of t will be? x1 bar minus x2 bar minus of d0, although d0 is 0 only. Over here d0 is 0 only, so we can ignore this even over, because s1 and s2 both are different. It will be 1 over s1 square over n1 plus s2 square over n2. This will be the value of your t, that is your test statistic. Test statistic t will be x1 bar minus x2 bar minus of d0, which is 0 only, under root s1 square over n1 plus s2 square over n2. This will be the value of your test statistic. If we will be keeping the values, x1 bar is your 525 minus of x2 bar is your 487 minus of d0 is 0 only, divided by under root s1 is your 57.5 square divided by n1 is your 16 plus s2 square is 49.5 whole square divided by n2 is your 12. So we have kept all the values. If we will be solving it, its value is going to come around 1.875. We can solve it, and if we will be solving it, its value will be around 1.875. Now, what is the degree of freedom for t distribution? Here we can see S1 is not equivalent to S2. So what is the formula for degree of freedom? Degree of freedom will be S1 square over N1 plus S2 square over N2 whole square divided by 1 over N1 minus 1. That is your S1 square over N1 whole square plus 1 over n2 minus 1 s2 square over n2 whole square. This is how we will be getting the value of degree of freedom. This is the formula for finding degree of freedom. We have learned when s1 is not equivalent to s2, then this is how we will be getting the value of degree of freedom. Now if we will be keeping all these values, it will be 57.5 is the value of s1 whole square over n1 is your 16 plus S2 is 49.5 whole square divided by N2 is 12, then whole square divided by 1 over N1 is 16, 16 minus 1 will be 15 multiplied by S1 square, S1 57.5 whole square divided by N1 is 16 whole square plus 1 over n2 is 12 minus 1, that is 11, s2 is 49.5 whole square divided by your 12 square. If we will be solving all these, your value will be around 25.43. Its value will be around 25.43, but we cannot take degree of freedom in the decimals, so we'll be taking it equivalent to almost your 25, because degree of freedom cannot be in decimals. There won't be any chances like 25.43% are having chances, are having your degree of freedom. It is not possible. That's the reason it will be your 25 will be taking. Now at degree of freedom 25 and your level of significance over here is your 0.05. 0.05 is the level of significance given. At this value, we have to find the critical value. Critical value will be T alpha at degree of freedom, that is your 25, and alpha is equivalent to 0.05. Value of T alpha will be 1.708. This will be the value of T alpha that we'll be getting from the table. What we had done is we got the value of T, we got the value of your degree of freedom, and now at this degree of freedom and at this alpha, the value of your T alpha, that is critical value, from the table we can get it will be 1.708. Now the third part is what is the rejection rule. So what rejection rule says, that reject your null hypothesis if absolute value of T is greater than equivalent to your T alpha. If the absolute value of T is greater than equivalent to T alpha, then reject your null hypothesis. Now just over here we can see that value of T, absolute value of T is your 1.875 and value of T alpha, it is your 1.708. So we can see that the absolute value of T is greater than your T alpha. And if absolute value of T is greater than your T alpha, that simply means we can conclude that we are going to reject your null hypothesis. That simply means null hypothesis will be rejected and your alternative hypothesis will be accepted. That simply means this will be accepted and this is going to be rejected. So what we are going to accept is alternative hypothesis will be accepting, that is your mu1 minus mu2 is greater than 0. This is going to be accepted and your null hypothesis will be rejected. This is how these type of questions will be solved. Hope it is clear to you what all we have understood. That means how we will be calculating the t-test, how all these will be done. This is all from this chapter. Thank you.